All right, guys, next piece in line is the connecting rod crank arm. Crank arm. I have marked up all the surfaces that they have left excess material on, and the burrs on the front side here are just atrocious. And that is indicative of a dull cutter or the rotation of the cutter spinning this way as it goes across this edge. There's no burr on this side. There's minimal witness burr on this side, which would indicate that the cutter was spinning clockwise and cutting the pressure into the part. The track on the part looks exactly the same, so I would think that this was probably cut and went back and cut and went back instead of going over and back, which caused this enormous burr. It's going to be a lot easier just to hold this in a collet and face this off a thousandth or two and turn this diameter down at the same time, since that diameter does need to be addressed. So that'll be the first step in line, and then we'll see where we go from there. There's a couple of little corners here that need to be taken off. The radius tool didn't quite get to that. And that's just a setup thing. I guess they went for a better mate down here than they cared about up here. And this little surface right here, that small land does not need to be addressed. So if you don't like the way that looks, cut it off with a file. This does need to be thinned out. This turns into a fork. There is a thread on one side of this and the other side's a through hole. I may turn this 5BA into a 540 Imperial because I just don't like single pointing metric threads that short. It's just with an undercut, I just don't like it. So we'll see what happens. First op, pop it in the lathe, face it, just barely cut anything off here, and then dust the OD. And we'll probably move over to the mill and start popping holes in it. Let's do it. We're going to remove the burrs off the front of this piece because I'd be sitting for a month of Sundays trying to file these off. And it's just as easy to take a nice dust cut and clean up that front face, maybe a thousandth or two, not knowing exactly where everything is. The OD is called out on the print as a finish dimension, and we're going to shoot for that because that's, well, I mean, it's a good time to hit it, right? They left that piece on the back for a reason, and before you go slicing anything off of a previously supplied casting or a pre-machined part, make sure you double check it and try to figure out why they left it for you. And I have to say, big thumbs up to the guys at Stuart for doing this. It was a huge help. Small chamfer on the front. This particular tool here is actually a tree pan tool, but the grind on it is perfect for removing those four black corners and taking it into the cylindrical feature on the front. Now, moment of pure honesty here, guys. On one of these parts, I went just a little too far, and I put some flats on the inside radius of that, and I had to file them out, but, you know, it is what it is. Let's take a look at this part before we start to machine it. What I would like to do is set it up in such a manner that I can access as many sides and many orientations as I possibly can in one setup without having to actually physically take the part out of the fixture. Now I could do this on a plate and just flip it over and then pick it up and trust everything's about center, but I intend to do it in a spin indexer locating on the same protrusion that allowed me to turn and face the 3/4 diameter. The very first operation in the final machining of this part will actually be the two holes that hold the halves together once this thing is cut apart. Now I have a very good reason for that. This little boss on the end here is the center of the universe. Well, I mean, it's the center of the part anyway, right? So we're going to find the center of that part, or the center of that casting. And then we have to find the center of the hole down here, which is just this simple X move. The thickness of this is considerably oversized. It's about 3/16 oversized, about 5 millimeters worth of extra material. That tells me that if I wanted to, 5 millimeters in the other direction, I could put another feature that when they're cut apart, and that 5mm is removed, I have half a hole here and half a hole here. And then when they come together, naturally 2 halves make a hole. So there you go. I will do that. I will not do this final size in this setup because I want to put this thing together as it will be at installation and then bore or ream the final journal size. In order to cut that off to the final dimension that I want to cut it off to, I'm going to come down in that same setup. I'm going to go about 3/4 of the way, halfway through both sides, like so. And then I'm going to have to deal with this tiny little web here. And I can do that across a bandsaw and then just file off or machine off the little nub, and the 2 sides should fit. Well, I think you can see at that point it's easier to have the holes already in it than not. So that is the plan. First operation, meatball setup, pop the 2 holes, one here and one here, all the way through. Going to use these little bolts here to hold this guy together when we're done. It goes through and naturally cinches up with a nut. That's op 1. Then we're going to go to the spin indexer. I think you're going to like the little jig I made to support this in a spin indexer. Holding here, any milling and drilling out here has a tendency to want to jump the part, diving board the part, chatter, spring, lift, grab, bark, puke, fart, whatever you want to call it, but it's going to do something. So we have to support it. And I've got a little extension V block that'll support it nicely. All right, enough talking. Let's throw some chips. Set up for this operation is a 1-2-3 block with a parallel clamp to the back. That gives me a rear and a right side registration surface, and I know that the diameters of these 2 pieces are the same, so is the thickness. So as long as I drive the part into the formed corner by the setup, I know that I'll have what I can believe to be a repeatable, reliable feature here, but I will still indicate it. First step was to indicate this part, get it to run 0 right where it sits. Now beware, if you do this, the thickness of this part up top is thinner than this boss down the bottom, so make sure you have a block behind this. You can't see it, but there's another 1-2-3 block behind that. So it is considerably longer than it looks from here to there. 2 inches to be exact. Let's drill some holes. Once you add up the diameter of the center drill and the diameter of the boss that is left there, that center drill is almost perfectly tangent to that remaining boss. So don't use a 3/16 diameter center drill to do this. Use an 1/8 or something under 1/87. Now that took a few extra pecks. I was being very delicate with this because it's only held on with a clamp. This is a can't twist clamp for everybody that's going to ask. This is a 1 inch and the parallel is being held on with a 2 inch. I was keeping my eye on the gap between the block and the part, making sure the part did not move, especially on this hole out here. The downward pressure could have easily pivoted the part off the block, and then you would have lost your center to center. Off camera, I will do the second part, then we're going to change setups. Well, I know this might look a little bit over the top, but I think it's going to work out just fine. This is a piece of aluminum that I've rigged onto my vice stop. And the vice stop was just perfect for getting everything that I needed right where it needed to be. It is a small nesting V-block in there, and this gap right here is bigger than the part diameter here, so the part can pass through here. The shelf is relieved, so the body of the connecting rod can shift forward and come up and out for the second part in line. I haven't done any of the parts yet, but this is the theory anyway. It is indicated flat here, rotated 90 degrees, and then indicated flat across the column. I then took an indicator and I found a high spot on this side, high spot on that side, and the reading that I got side to side was then the reading that I looked at for the top when I rotated the indicator 90 degrees. So in 3 points, the 90-degree reading of the indicator, 2 90-degree moves, the indicator read the same. It looks a little off-center because this side of the casting doesn't have the same chamfer as this side does. So You know, I didn't do that, so I really don't know what to tell you. It still has the capability to turn, which is good. I can put the split feature in here. I can drill it, I can tap it. I can put the holes in down here. I can do my split work and pretty much access everything that I need to access from this particular setup without really moving anything. When it was in this presentation here, it was brought into concentricity to make sure it was running true with the collet. I swept the outside, zeroed it, moved down, swept the outside of the smaller diameter, zeroed that as well. So I know this thing is running dead true and not influenced by this block. That was a really sensitive setup to rotate everything, and once you tighten it down, everything starts to shift a little bit. I did not want to move that just for that reason. I'm going to start with the through hole and the tapped hole. Sorry guys, I'm not going to go with the BA threads on this particular feature because it's just too small for a single point indication or a single point threading, and the dies would consume most of the thread for this area. That's very little margin of error for that. So I'm going to change it to a 540, something I'm comfortable single pointing. One side's a through hole and the other side is the tap. Then we're going to spin it 90 degrees like this, knock the center out of it, and that's when you'll see the features show up. Then another 90 degrees, go back for the first connecting rod hole, shift off center, put another hole in, and then we'll chop it up, and this is all going to make sense here pretty soon. Stay tuned, let's go. All right, now just like they say the camera cuts off 10 pounds to the actor, I have to say that any movement that you are seeing on your screen, I cannot see with my naked eye. And actually, after the fact, after I watched this video, I rolled this back and I grabbed a hold of this setup and I tried to move it, and I could not detect any movement in the setup. But if you look real close, you're going to see some bounce going on. If that's a problem, if that's a concern, by all means mount everything to the table and block it up as securely as possible. When the critical features come along, move really slow, move really cautious, change your pressure, and you should be good. The first hole that I'm going to drill here is right on the calculated split center line. I will later come back with an end mill and walk this into an elongated feature so that once it's split, the remnant remains will be a round circle. It'll make sense. Hang in there. To assure that the edges of this particular rod are true to the center line, I elected to leave the end mill where it was and rotate the part. So without the table moving, the end mill is creating both sides, and as you can see, it is creating both sides exactly the same spot from the center of rotation. The cutter that I'm going to use in this segment is considerably undersized from the final geometry, and I'm just going to nibble away at it in a manner of machining that you've probably seen me use in other videos.
I'm going to come clear of the part. I'm going to advance the table a little bit and just take a little bit of a bite. And it just works out really well. That is a 250 shift. That's about a 6¼ millimeter shift from the center line of the cross hole. And now calculating the dimensions on the print and the diameter of the cutter, I'm going to make a couple of y-axis shifts here and walk down the inside of the one, across the back side of the pocket, and off the inside of the other.
This area has to get thinned out next, and then we put the relief slots in it and take the part out. All right, I think the utility of using an indexer is very obvious, and also the tool path that I just took, the up and back, driving the chip in, results in a really clean, I'm not going to say non-existent burr, but closest you're going to get to it. Measure up the thickness, make an adjustment, finish the thickness. Now this is the area that needs to fit between the journals on the crank, so control this one pretty tight. If anything, go a couple thousandths smaller. Now those of you that may build this engine and those of you at Stuart, I want you to take note of the next feature I'm going to put on here. The next feature is not on the print, but if you're an engine guy or you've been greased under your fingernails for any great length of time, you're going to appreciate this one. I'm going to rotate this from the last position. I'm going to rotate it 90 degrees, and I'm going to address the face up here, right at the tip of my finger. I'm going to get a much smaller end mill, and I'm going to walk into that face, and I'm going to put a flat on there that interferes with the head of the hex bolt that drops down in there, so the hex bolt won't spin when you are tightening the bottom nut. It's going to be very superficial, but it's going to be very beneficial. So let's get the officials out of the way and get this going. Let me switch to a smaller cutter. I'll be right back. And boy, that chamfer really does make that hole look off center, doesn't it? Light doesn't help either. All right, do it.
This little feature is not on the print, and it is a very useful, very helpful feature when it comes time to assemble this model. I have no numbers at this point, so I'm just going to trial and error this until I get that bolt to seat almost flat to the surface I'm creating. I don't expect it to sit flat because there's a radius on the underside of the bolt head, and until the chamfer on the hole is there, the bolt will not sit flat.
There we go. Okay, that flat will officially trap the hex while you tighten up the nut on the bottom side, and everything should end well. The hole needs to be deburred because there's a radius on the underside of that particular bolt, but you can see what that just achieved. I think that's a win. We'll do that to both sides, then we'll go for the relief cut.
Once I'm happy with how thin the web is, I will move the cutter left and right on the x-axis to create two finished surfaces, one for the top of the rod, one for the bottom. Rotate 180 degrees and continue to do that.
All right, I think you can see the benefit now of doing it the way it was done. I will simply put this across the saw and sand those webs off, and I should have two mating sides that are almost to print. I'm still going to have to put the bottom in and bring it to the final thickness, but I think it's going to work out. Let's pop it out, break it apart, check it out. Okay, after all the machining is complete, this is what we're left with. The top half is a finished surface from the inside of the split to the outside and from the center of the hole up. But now the trick is to break it apart. No, don't break it. Yes, break it. And don't get your finger pinched in there, I'll tell you, but that would hurt. Let's see. Try not to bend apart either, right? Going to take it over to the sander, knock these off, rub this thing down on some 400 emery. And don't worry about that inside chatter, that is a rough diameter. I'll be right back. It's a great technique. Be right back.
Before I assemble the part for the final boring operation for the crank journal, I want to bring the bottom, I want to remove the sacrificial material from the bottom lug and bring it to its finished dimension. Parting this is sufficient. You don't have to get anything critical here. It's not going to get in the way of anything. There's more than enough room to miss this dimension. But, put yourself into every dimension you try to hit. That is a really good practice. I'm going for the finished thickness on this. I'm going to part this off just a couple thousandths oversized, and then I'm going to run it on a piece of emery and cosmetically clean it up.
Next step in the process is to bring the journal diameter to its final size. I'm going to go 1/1000th of an inch over the final size. The final size of the crank material going in there is 281. I'm shooting for a 282 pin to drop in there. This has been indicated straight. I indicated the hole, and I'm moving back the dimension on the print to give me the center to center requirement. The final size of this hole is just about 7.2 millimeters. Slightly less. There we go. When I bore a hole and I don't feel like taking very small incremental cuts, I start with a pin that's 10 thousandths undersized. If the pin doesn't go in on the previous cut, I know that I can dial in 10 more on the boring head and take relatively decent sized bites. This is 272. This is a quarter of a millimeter. This is 0.25 of a millimeter, 10 thousandths below where I want to be. So now I know I can't take anything bigger than a couple of thousandths or I will blow this hole up. And we'll start off with 3 at a time and see how that works out. Beauty. Let's move over to the lathe, make an arbor, put the outside registration areas on this, and call it done.
The beauty of a setup like this is that you are not removing the clamping surfaces that the arbor depends on. So all your diameters, all your carriage shifts are all exactly the same from side to side. So it makes a setup like this really beneficial and really quick. Once this side is done, I will take this part off, flip it, and go to exactly the same carriage and cross slide numbers for the opposite side. Works like a charm. Just don't get your fingers in the way because it would not end well. Be very cautious on a setup like this.
All right, unless I miss something, that is the final op. Let's pop it out, put it on the bench, and take a look. All right, let's take a look at the final product here. Round protrusions on either side to contact the bearings in the cylinder base. One thou over. This is the actual material that will be used to fabricate the connecting rod itself, or the crankshaft, excuse me. So we got a real nice fit on there. Very pleased with that. The little notches on the top that I put in that were not on the print, they worked out fantastic. You don't want to go too deep with those because then you'll run out of thread on the studs that they provide you. But I can promise you there's a whole lot of work in these parts that wasn't in this video. A lot of indicating, a lot of numbers, but there you go. I hope that you got something out of that. This was a very involved little part. And I made it my own by putting a 540 in there instead of a 5BA. So all you metric guys, or non-metric guys or BA supporters or whoever that are offended by the fact that it's a 540, oh well, it's my model. So there you go. Happy with the results. I thank you very much for spending some of your day with me watching this video. This was an awful lot of work, but it was an awful lot of fun at the same time. So wherever you are in the world, I hope you're well and happy and safe. All of the above. I am Joe Pye here at Advanced Innovations in Austin, Texas, moving along. Thanks for watching. I'm out.